In a previous video, I've taught to you how to determine the empirical formula based on 3 different methods, but I didn't use and show any calculation to you. So we are going to focus one by one, but in this video, we are going to focus for the first method by using the masses of compounds. This is example when you have the masses of constituents based on example 7. You have 18.3 gram of sample of hydrated compound. Please be careful here. I put the term hydrated compound. So it means that one of the elements in your Marmora table should be water. Next, I have the mass of calcium, mass of chlorine, and mass of water. So you have to determine its empirical formula. First, let's draw Marmora table. What is Marmora table? Marmora table is referring to mass, moles, and ratio. So you should have these 3 as your requirements for Marmora table. So let's draw your table here. This will be the row for your table. I have here where my elements, I put the one which mentioned first or in alphabetical order. You can see that calcium first, chlorine, and followed by H2O. Why H2O is not separated? Because this is for hydrated compound. It's a bit special. That's why I need to explain this example to you. Now we have mass. Don't forget the units. Gram. Moles, the unit is mole. And the simplest ratio of moles. So in order for you to find out this value, you are going to put everything in this Marmora table. Let's do the first one, mass of each element. You have those values which are given in the question. Just put in the table and make sure you put the units here. If you left the units here, you have to put each of them. So better to put it here. Next, you have to calculate the number of mole. Once you got the mass, you can calculate the number of mole by using mass over molar mass for each element. So, I'm going to calculate based on the element given. For calcium, I will have 0.10. For chlorine, I will have 0.20. And for water, I will have 0.40. The next one, I'm going to determine the simplest ratio of moles, but you need to choose the lowest value of mole. Based on these 3, you can see that the number of moles for calcium is the most smallest. So I'm going to put this as denominator. So I will have my simplest ratio for calcium first, which will be 1.0. The next one, I will have simplest ratio for Cl, which will be 2.0, and for water will be 4.0. And once you calculate that, you have to put the final one, which is a whole number. So I got for calcium will be 1, for chlorine will be 2, and for water will be 4. So when you want to write down the empirical formula, the value, the whole number here is going to be subscript, or more specifically lower subscript. So I'm going to write down this one, Ca. Usually we don't put 1 here because we can understand it's already 1. I hope you can understand Ca, you got 1 here. And then for Cl, I have 2, so lower subscript 2, dot. And then, this is a special thing about hydrated compound. You have to put this whole number at the front of water. And don't forget the dot symbol to emphasize hydrated. So that's why the empirical formula for this compound will be CaCl2 dot 4H2O. So I hope you are clear how to determine the empirical formula from masses of constituents. That's it for this video. I'll see you in the next one.